Hi, good morning. This is Trina here to discuss about atomic theory. So in the atomic structure, today I will tell about the Rutherford's model, postulates, drawbacks as well, and also the Bohr's theory. And in my personal information, I have given my contact number and email ID. So if you have any doubt, you can communicate with me. And the most important part, that is the course page. Here I have uploaded entire study material and also the solve problems and semester questions. So if you, first of all, you have to, with this code, we have to do the registration, then you can access entire study material. So in this subject, the chemistry subject, the code is CH101 for odd semester, CH201 for even semester. And this course is for undergraduate BTech students, and the streams are CSE, IT, Civil Mechanical for even semester and Electrical EC BME for odd semester. The credits 3, contact hour 35, and weekly I will take 3 lectures. The prerequisite knowledge required to understand this concept, that is the 12th standard. So in the course objective, you will learn that different concepts of chemistry. And in the outcome, course outcome, students can describe the fundamental properties of atoms and molecules, atomic structure from the atomic structure topics. And here also I have given the lecture plan. So it is the entire lecture plan. From this you can understand that in which day which topics will be covered, so that you can go through the prior my lecture, go through the content prior my lecture, so that you can ask question and go through the interactive session. So this is the first module. Here you can see the module 1, atomic structure. Okay, so this is the module 1, atomic structure. And today I will tell about the first lecture, that is the Rutherford's model, postulates and drawbacks as well, Bohr's models and drawbacks. So here from this lecture, from the atomic structure, students will be able to describe fundamental properties of atoms, molecules and atomic structure. And you can go through the books, you can avail the books from the library if you want. Okay, so I think that you have some idea that in an atom what is there. Like there is the nucleus inside and the electrons, the negatively charged electrons moving around the nucleus. And you know the nucleus contains that proton and neutron. Proton is the positively charged and neutron, it is the neutral. But how we know this? Okay, we can't see with our naked eye, we can't see the atom structure, atomic structure. So how this concept came? So there is a great history. So first, Sir Ernest Rutherford, the New Zealand-born physicist, described the famous atomic model or planetary model of the atom in 1911. According to the model, the atom is described as a tiny, dense, positively charged core called a nucleus, in which nearly all the mass is concentrated around which the light negative constituents called electrons, you know, the negatively charged, circulate at some distance, much like planets revolving around the sun. So here you can see the figure, that is a structure. Like at the center there is a nucleus. Okay, here is the nucleus. Now nucleus, you got it. Here is the neutron and then proton. Proton is positively charged, neutron is neutral. And the electron orbits, these are the orbit, and this is the electrons. These are the electrons, the negatively charged electrons. So this is the Rutherford model of atom. Now how he got this idea? So he did an experiment. So this is the Rutherford atomic model experiment. So what he did in Rutherford's experiment, he bombarded light energy streams of alpha particle on a thin gold foil of 100 nanometer thickness. The streams of alpha particles were directed from a radioactive source. He concluded the experiment to study the deflection produced in the trajectory of alpha particles after interaction with the thin sheet of gold. To study the deflection, he placed a screen made of zinc sulfide around the gold foil. Okay, so now I will show the experiment how he did it. Then you can visualize and you will be more clear about it. Okay, you follow this. This is the Rutherford alpha scattering experiment. So this is the apparatus and it is the alpha particle emitter. You can see here. It is the slits detection screen. Now we are in the procedure part. So here you can see how the alpha particle will come. So it is the beam of light. So you can see this. So it is the beam of light alpha particle emitter. So alpha particle emitted and going through the slit, passing through it. Now here you can see the 100 nanometer thickness of gold foil. So alpha particle falling on the foil, then what happens? It going to the different direction. Most of the radiation is passing through the gold particle, but few of them are going back. So basically it is unnatural, unexpected results, because if there is nothing, so all lines should be passed through it. But there is nucleus. That is why few of the light is going back. Okay, so here if there is nothing, so all the light should pass through it. But it did not happen. What happened? So as there is the nucleus, so few of the light reflected back. So from this experiment, Rutherford drew the conclusion. So what was the conclusion? Okay, let's see what was the conclusion. So on the basis of the observations made during the experiment, Rutherford concluded that is very much important. Number one, what he saw. What was the observation? Number one, measured space in an atom is empty. A large fraction of alpha particles pass through the gold sheet without getting deflected. Therefore, he concluded, so first from the experiment, he saw that a large fraction of alpha particle pass through the gold sheet without getting deflected. So, therefore, the major part, he concluded that the major part of atom must be empty. What is the second? The positive charge in an atom is not distributed uniformly and it is concentrated in a very small volume. How he draw this conclusion? So what was the observation? Observation was that few alpha particles when bombarded were deflected by the gold sheet. They were deflected minutely and a very small angles. Therefore, he made the above conclusion. Okay. Next is a very few alpha particle had deflected at large angles or deflected back. Moreover, very few particles had deflected at 180 degree. Therefore, he concluded that the positively charged particles covered a small volume of an atom in comparison to the total of an atom. Okay, so if you want to see the structure, you can remember that all the beams of the light, okay, here also you can see that very few deflected and very few deflected back at 180 degree angle. Okay, so you understood that how he, what was his observation and how he concluded. So he, after that, he drew some postulates. So what are the postulates of Rutherford atomic model based on the observation and conclusion? So number one, an atom is composed of positively charged particle. Majority of mass of an atom was concentrated in a very small region. This region of the atom was called as nucleus. Okay, so you know it very well that in center that there is the nucleus and there is the positively charged particle. And it was found out later that the very small and dense nucleus of an atom is composed of neutron and proton. So you know that proton is the positively charged, neutron is neutral. Next, number two, what is the next second postulate? That atom's nucleus is surrounded by negatively charged particles called electron. The electrons revolve around the nucleus in a fixed circular path at very high speed. So these fixed circular paths were termed as orbit. Okay. Number three, an atom has no net charge or they are electrically neutral. Because electrons are negatively charged and density concentrated nucleus is positively charged. A strong electrostatic force of attraction holds together the nucleus and electrons. Number four, the size of the nucleus in an atom is very small in comparison to the total size of an atom. How we understood? Because very small deflection were there. From this, he drew the conclusion. So here you can see again the structure, Rutherford model of the atom. So here is the nucleus and these are the electrons. Okay, so you have learned that the Rutherford experiment, the postulates of his models, but there is also limitation. It is not the flawless. Okay, so what was the limitations of Rutherford atomic model? So these are the limitations. Rutherford experiments was unable to explain certain things. What are those? Rutherford's model was unable to explain the stability of an atom. According to Rutherford's postulate, electrons revolve at a very high speed around a nucleus of an atom in a fixed orbit. However, Maxwell explains the accelerated charged particles release electromagnetic radiations. Therefore, electron revolving around the nucleus will release electromagnetic radiation. Next, number second, the electromagnetic radiation will have energy from the electronic motion, as a result of which the orbits will gradually shrink. Finally, the orbit will shrink and collapse in the nucleus of an atom. According to the calculation, if the Maxwell's explanation is followed, Rutherford's model will collapse with 10 to the power minus 8 seconds. Okay, so therefore Rutherford atomic model was not following Maxwell's theory and it was unable to explain an atom stability. Number 3, Rutherford's theory was incomplete because it did not mention anything about the arrangement of electrons in the orbit. This was one of the major drawbacks of Rutherford atomic model. Okay, so you have learned that what are the drawbacks of Rutherford atomic model. So it could not explain the atom stability and it was incomplete because it did not mention anything about the arrangement of electrons in the orbit. So next scientist, Niels Bohr. So he modified the Rutherford model. So Bohr's theory to hydrogen-like atoms and ions. The objections of Rutherford atomic model was contested by Niels Bohr atomic model in 1913. He proposed the quantum theory of an atom. The theory was based on the quantum theory of radiation. Bohr retained the main postulates of Rutherford planetary model and did some modification on the basis of quantum physics. Hence, Bohr atomic model is also known as Rutherford-Bohr atomic model. It is called Rutherford-Bohr atomic model. He depicts the atom as a tiny spherical body which consists nucleus at center and negatively charged particle electrons revolving around the nucleus in a certain path known as orbit. He proposed some new postulates with same basis concept of Rutherford theory. Okay, so you got that, that means it is improving. We are getting the modification and ultimately we have got the current structure Okay, so this is the Bohr's atomic model. Is the Niels Bohr. So in order to explain the stability of an atom, Niels Bohr gave a new arrangement of electrons in the atom in 1913. According to Niels Bohr, the electron could revolve around the nucleus in only certain orbits. Okay, so Niels Bohr gave the explanation of the stability. He told that in a certain orbit, that means the electrons can revolve around the nucleus. So that means the electrons, like our solar system, so the electron must have the specific orbit. This is the called energy level. Okay, so these orbits are called energy levels. Each orbit having different radius. When an electron is revolving in a particular orbit, then or particular energy level around the nucleus, the electron does not radiate energy or lose energy even though it has accelerated motion around the nucleus. So here you can see the structure, see the picture. So here is the different orbits. Okay, here you are getting different orbits. N is equal to 1, n is equal to 2, n is equal to 3 in this way, and it is as per the energy level. So when it is closer to the nucleus, it is the lower energy level, and if it is far from the nucleus, that is at the higher energy level. And this del E, that is equal to h nu. So in this way, the Niels Bohr explained the stability factor. So what he told, that only there is a certain orbit, the energy level, each orbit having different radius. So you can see from the structures, from the picture, that there is different radius. The electron does not radiate energy even though it has accelerated motion around the nucleus. Okay, that means when it will go, that means it will remain with the same energy level when it will move through this orbit. So, what are the postulates of Niels Bohr atomic theory? The important postulates in his theory is, there are different postulates. Number 1, electrons revolve round the nucleus with definite velocities in concentric circular orbits situated at definite distances from the nucleus. The energy of an electron in a certain orbit remains constant. As long as it remains in that orbit, it neither emits nor absorbs energy. These are termed stationary states or main energy state. Okay, these are the stationary states or main energy states. Okay, the next postulate, number 2. The Bohr proposed that the angular momentum of an electron is quantized. Thus, the motion of an electron is restricted to those orbits where its angular momentum is an integral multiple of h by 2 pi, where h is Planck's constant. Number 3, thus we have the relationship mvr is equal to nh by 2 pi, where m is mass of electron, v is velocity of electron of said orbit, r is radius of that orbit, n is a simple integer. The stationary states or allowed energy level are only those where n is equal to 1, 2, 3. This is called Bohr quantum condition. Number 5, the energy of an electron changes only when it moves from one orbit to another. An electronic transition from an inner orbit to the outer orbit involves absorption of energy. Similarly, when an electron jumps from an outer orbit to the inner orbit, it releases energy. That means I told that inner orbit is the lower energy level and the outer orbit is the higher energy level. So if the electron gain energy, it will go to the higher energy level, and if it comes in the lower energy level, inner orbit, it will lose or release energy. So either it will absorb energy to go to the higher energy level, higher orbit, outer orbit, or it will come, if it comes to the inner orbit, it will release energy. The energy thus released in the form of a radiation of a certain frequency appears in the form a line in the atomic spectrum. If the energy of an electron in an outer orbit is E2 and energy of electron in the inner orbit N1, E1, then E2 minus E1 will be equal to del E is equal to h nu. That is the difference of the energy level. The value of n could be small integers 1, 2, 3. Those correspond to the first, second, and third, and so on. Quantum states are cells for the electron. N is termed as principal quantum number. Okay, so later I will describe the all quantum numbers. Based on the Bohr theory, he calculated the radius of various orbits and the energies associated with the electrons present in those cells. Okay, so all these are the postulates of Bohr's theory. So you understood, and you can see that how gradually we are getting the ultimate electron atomic structure. So this is the Bohr model, the proton at the nucleus, electron orbit, and also you have seen here, basically here you have seen that it is the structure, it is the as per the Niels Bohr model. So here is the different orbit, n is equal to 1, 2, 3, and so on, and each orbit has definite energy level, and when any electron moves through this orbit, it will it contain the same energy level. If it goes through, say, the higher energy level, if it goes to the higher energy level, say from N2 to N3, it will absorb radiation. If it goes through the higher to the lower energy level, it will release energy. Okay, so you have understood the Bohr's postulates. So if I summarize today's lecture, so what you learned today? Number 1, you learned the Rutherford postulates and his observation and the conclusion. based on the Rutherford experiment with the gold foil. Then you have learned the drawbacks of the Rutherford model, and then you also learn how the Niels Bohr modified the Rutherford model and what are the postulates of the Niels Bohr model. You have learned this. So from here, generally you will get the questions like this. I am showing you that write down the postulate of Rutherford atomic model. So you can write what are the postulates, write down the limitations of Rutherford atomic model. So you can write the limitation. That means he could not explain the stability of the atoms. Number 3, write down the postulates of Niels Bohr atomic theory. So you can write all these things. So I hope that you have well understood about the atomic structure, Rutherford model and the Niels Bohr model. So if you have any doubt, you can communicate with me. And for today, I am ending my session. So thank you everyone.